Hey there, and welcome to the next video in my Functional Programming in Python series. If you missed the first video where I talked about what is functional programming anyway, and how can you represent data in immutable data structures for use in your functional programs, then you might want to check out the first part of this series before you watch this video. So in this video, we're going to take the next step and we're going to work with this immutable list of scientists that we created in the previous installment, and we're going to do some interesting transformations on the scientists in that list, or just on that data set, by working with the filter function in Python. So the filter function is one of the functional programming primitives that you can use in your Python programs. It's built into Python. So here I'm on Python 3, but this would also work on Python 2. The filter function is built in, and it has maybe a slightly complicated doc string. So it says here, the filter function returns an iterator yielding those items of iterable for which function of item is true. If function is none, return the items that are true. Okay, what does that mean, right? That's pretty intense. So, well, we're just gonna play with it, and then you can see how we can use the filter function to play with this data set and to apply some filtering. And what I want to do now is I want to write a filter function, a filter expression that gives me all of the scientists in this list, or actually gives me a new list of scientists that have won the Nobel Prize, or the opposite, right? Like we want to filter this data set by whether or not that person won the Nobel Prize at some point. And so, okay, let's take this step by step, right? So I've got the filter function here. Looks like this takes another function object. And if you want to define a function object in line, you can use the built-in Lambda expression. So here I'm going to say Lambda x. So this is the object that will be passed in. So Lambda of x, I want this to return true or false depending on whether or not the Nobel flag is set to true or false. So I can go here and I can say x.nobel is true. So if you're wondering how Lambda works, it's basically like a one-line function, like a shortcut for defining a function in Python. So you can put arguments, and then you have one expression that gets evaluated. So you don't have to do return or anything. That's automatic. And it will just evaluate this expression and return it back out of the function, out of the Lambda function. So in this case, I'm just comparing Nobel to true. I could have shortened that and just said x.nobel, but honestly, I think this is nicer because it actually makes sure we're returning a Boolean, and I think that's the better way to do it. So in this case, I would say, all right, we're checking here and we're passing in an iterable, which is the list of scientists here. Okay, so what do you think is going to happen when I run this? Okay, so depending on whether you're running this on Python 2 or 3, you're going to see a different result here. So in Python 2, this will have created a list object containing all of these filtered scientists that are the scientists that passed this test here. So this is like a test function. And on Python 3, this actually returns a filter object, which is an iterable. And yeah, it's an iterable. It works like an iterator. So we need to extract the next item from it. And well, actually, why don't we do that? Let's call this FS for filtered scientists, and then we can just say next FS, and that's going to give me all of these filtered scientists. And you can see here, this only contains scientists that had Nobel set to true, and now we're hitting a stop iteration exception, and we're at the end of that. So if you're wondering how iterators work in Python, I have a tutorial on my website at debater.org that I'm also going to link in the description, and you can go there and you can kind of dive into that topic if you're interested. So what I want to do now is actually turn this into what I promised you earlier. I want to turn this into another list, or I guess a tuple, to make it immutable, of these filtered down scientists. So what I can do here is we could say, okay, like basically what I'm going to do here, I'm going to bring back this filter instruction, or this filter function call, and I'm going to call tuple on it, and that will take all of the elements generated by this iterator, and it will put them inside a tuple that we can then refer to, right? So, if I wanted to make this prettier, I could do this, and then pprint fs, and then you would see that it's filtered down to only include Nobel Prize scientists. So the filter function is pretty cool because it allows you to apply a function over a whole list of things, or an iterable of things, and then every item in this list or in this iterable gets passed to the function. In this case would be x, and then we can make a decision and return true or false. And if we return true, this item will be included in the resulting list, in a filtered list, and if we return false, it will not be included. So maybe to show you how that works again. So I'm gonna make this slightly crazy expression here, right? So here, I just want to type out a skeleton here, scientists. Okay, so what I'm doing here is I defined this expression here that would actually convert it to a tuple and then print it out so it looks nice and clean. And I didn't yet add the filter function, which we're going to do now. So in this case, I could just always return true. So if the filter function would always return true, then we were just going to return the whole list, right? And you can filter on anything you want, right? I could say, okay, if x.field equals physics, we're only going to get people that, well, worked in physics. And if I can go x.field equals physics and x.nobel, let's actually use the short version this time, x.nobel, then I get a tuple of length 1, because that's the only person, Marie Curie here is the only person that this filter expression matched on. And why do it this way, right? Like why should you write code like that? Why not do it differently? Like why not do for x in scientists, and then if you have x.nobel is true, then print x. Just the same result. Why not do a for loop? Well, what's kind of nice here is that you can chain these things very well, and you can apply these transformations in a purely functional way. So when you look at this expression here, this is just calling a bunch of functions. Like we're not iterating over a list. We're not having these side effects where we're printing stuff out. And in some ways, of course, it seems more complicated than having this simple loop here. But what's really nice is how declarative this is, right? We're just saying, hey, okay, we'll take this list of scientists, apply this filter function, whatever it is, make sure we have a list at the end of it, and then print it out. So it's like this long chain of function calls, and that allows us to do this transformation in a single line here. And it's not really about like the number of lines of code, but we're doing this with these like very, very simple composable things here. We're using the pprint function, we're using the tuple function, we're using this filter function that could be reused. And these are all little building blocks that I could just reuse in different contexts, right? If you imagine I did this, let's call this Nobel filter. It takes an x, and then it returns x.nobel is true. All right, so now I've got this Nobel filter, and now we can go in and we can say, okay, filter on this Nobel filter. And then again, we want the tuple, and just for clarity's sake, we also want the pprint. And now I have a reusable piece, right? I have a reusable piece. I have this Nobel filter. I could define a bunch of other filters that can just be applied without me having to rewrite this code or copy and pasting a bunch of code. So now everything we use here it's just a series of function applications, and it becomes clearer when I do it this way than with the Lambda, I guess, because the Lambda is kind of ugly, and a lot of people in Python, they don't really like it. And by the way, before people leave angry comments, I'm not necessarily encouraging this style of programming, because it's not really what Python was meant to do. Arguably, this would be a better way to do it. But it can be fun to think about how you can use a functional programming style that relies on function application or evaluating functions rather than writing stuff like this, and that mainly relies on immutable data structures, how that can sort of change your mindset a little bit, and it can make things a lot easier if you're working in parallel programming, for example, because I could apply this filter in parallel, and it would be very easy to parallelize that across several threads or processes. Like, actually, it could be an interesting exercise. Maybe I get to that as part of these tutorials to actually show you how to do that. And if you write your code in a more functional programming style, you can take advantage of these things. All right, so I hope that gave you a good idea of how the filter function works. Now, I can't really stop this part of the tutorial here without talking about list comprehensions, or I guess in this case we would create a tuple. All right, so in this tutorial we mainly worked on defining this filter expression here, this filter function call that filtered scientists by Nobel Prize or not, whether or not they won the Nobel Prize. Now, Python has this wonderful thing called list comprehensions, where I could say, all right, give me all the x's where x is in scientists, but only if x Nobel is true. So that is actually the Pythonic version of this filter expression here. That is what a lot of the Python core developers recommend as a replacement for the filter function. And you can see here this is slightly different to what we had before, but we can change the formatting. All right, it's pretty close. Now the only difference is that we're creating a list here, and previously we were creating a tuple. So what I can do here, I can say we're going to create a tuple, and then this is already pretty good, but we can do one better. So now these two are actually equivalent, right? I have the output here from this list comprehension, and from the filter expression, they're now actually completely equivalent. But there's one change I can make, and that is I can get rid of the list comprehension and actually turn this piece here into a generator expression, which will have the same result, but it's not creating a list object as an intermediary product here. So previously this would create actually, okay, I want to show you that this has the same result, right? So previously what I did, I pretty much did this 1 2 3. I'm creating a tuple out of a list, and you can actually do this one better by doing this. I mean, this doesn't really work, but this is kind of in the spirit of what this generator expression here did, right? So you can pass something like that, like a list comprehension. You can pass it directly to the tuple function here or any other function, and then if you don't have this wrapped in these square brackets, it will actually be a generator expression, which kind of it defines an ad hoc iterator that then produces these values for us without first creating a list and then creating a tuple from that list and destroying the list again. So it's more memory efficient, but that's kind of going down a rabbit hole of Python specifics here, which can be fun, but it's not really the point of this. So I just want to make sure that I'm covering some of the sidetracks here, because I know it's questions that come up when we're covering concepts like that, and I'm showing examples like that. All right, so now you should have a decent idea of how the filter function can be used in Python, how it relates to a functional programming style, and maybe you now also have a better idea of how list comprehensions work. So I know, the stuff we covered here at the end was a bit of a mouthful, and maybe it's something you want to review a little bit slower and actually type it out. And if you want to do that, I would encourage you to do it, because there's really a lot of cool things you can learn here. All right, and if you have anything interesting to add or have a question about this stuff, then please leave a comment. I'd really appreciate it. If you want to see the next installment in the series, so in the next piece or in the next part of this tutorial, we're going to talk about the map function, and that's another functional primitive in Python. And if you want to make sure you don't miss that next episode in the series, then click the subscribe button. I'd be happy to have you on board. All right, I'll see you in the next video, and happy Pythoning.